faster discharging tendency of cations and anions. This is today's lesson. First of all, let's try to simplify the name of the lesson. That is, faster discharging tendency of cations and anions. Let's see. Sodium chloride solution. During electrolysis, sodium chloride produces sodium ions, chloride ion, and water ionizes to some extent to produce hydrogen ion and hydroxide ion. At the time of electrolysis of sodium chloride solution, we see two types of cations and two types of anions. Which cation will be reduced first and which anion will be oxidized first, and why? This is today's lesson. Again, for acidified water, we see water acidified. Water produces hydrogen ion and hydroxide ion. At the same time, sulfuric acid produces hydrogen ion and sulfate ion. Here, one kind of cation, but two types of anions. Which anion will be oxidized first, and why? Let's see about copper sulfate solution. Aqueous. Copper sulfate generates copper 2 plus and sulfate 2 minus. Water is here. Water gives rise to proton and hydroxide ion. From these two cations, which cation will be reduced first? And from these two types of anions, which anion will be oxidized first? This matter depends on three factors. Let's see the factors. Number one, reactivity of ions. Number two, concentration of ions. And number three, nature of electrodes. These three factors are functional here. That is, which cation or which anion will be discharged first during electrolysis. This is today's lesson, so let's begin. First factor is reactivity of ions. Let's see reactivity of ions in electrochemical series. Cations and here anions. Cations are lithium, potassium, sodium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, silver, and gold. This is electrochemical series of cations. Here we know this is highly reactive metal, so its cation will be less reactive. Similarly, gold, this is inert metal, so its cation will be highly reactive. From this series, we are getting that from any two ions, the ion which is in lower position, that will be reduced first. From these two, magnesium will be reduced first. From these two, copper will be reduced first. From these two, tin 2 plus will be reduced first. The lower the position in the electrochemical series, that ion will be reduced first. This is about electrochemical series of cations. Now let's see electrochemical series of anions. Nitrate ion, sulfate ion, chloride ion, bromide ion, iodide ion, and hydroxide ion. This is electrochemical series of anions. The lower the position of the anion, that will be oxidized first. For example, for these two ions, bromide ion will be oxidized first. For these two ions, hydroxide ion will be oxidized first. Let's clarify the matter. Chloride ion, which is smaller in size, but iodide ion, which is bigger in size. This electron is strongly bonded here, but for iodide ion, this electron is loosely bonded because of the long distance between nucleus and electron. That is why iodide ion can donate electron easily. That is why iodide ion will be oxidized first, then chloride ion. So simply we can say that the lower the position of the anion, that will be oxidized first. Let's see the second factor. Second factor is concentration of ions. Let's see. Suppose 0.1 molar sodium chloride solution that produces 0.1 molar chloride ion, and in water concentration of hydrogen ion and hydroxide ion, basically concentration of hydroxide ion is 10 to the power minus 7 molar. That is, if we compare concentrations of chloride ion and hydroxide ion in the solution, then concentration of chloride ion is 10 to the power 6 times larger than hydroxide ion. So during electrolysis of 0.1 molar sodium chloride solution, because of the higher concentration of chloride ion will be oxidized first, then hydroxide ion. Though in the electrochemical series, chloride ion is above than hydroxide ion. So according to the series, electrochemical series, hydroxide ion is supposed to oxidize first, but because of the higher concentration of chloride ion will be oxidized first, then hydroxide ion, ignoring the electrochemical series of anions. This is about concentration of ions. Concentration of ion will be prioritized than electrochemical series. Let's see the third factor. Third factor is nature of electrodes. Let's see the matter in detail. Suppose electrolysis of concentrated sodium chloride solution. Here cations are sodium ion and hydrogen ion, and anions are chloride ion and hydroxide ion. When platinum is used as cathode, then hydrogen ion will be reduced first, because hydrogen ion belongs to the lower position than sodium ion. In case of platinum electrode, hydrogen ion will be reduced first to form hydrogen atom. Another hydrogen ion will receive electron and form another hydrogen atom. These two hydrogen atoms form hydrogen gas molecule. But when here mercury electrode is used, then what happens? When mercury electrode is used, then sodium ion has greater tendency to mix with mercury to form alloy, and there it will receive electron and form sodium atom. This sodium atom combine with mercury to form sodium mercury alloy. So discharging tendency depends on nature of electrodes as well. This is all about faster discharging tendency of anions and cations. No more today. Thank you very much.